Hello, in this lecture we will find the radius of a circle. You can see in the drawing a circle. The center of this circle is at point O, and chord AD is at size of 10 units, while chord BC has size of 5 units, and we have this angle that is 90 degrees, and we want to find out the radius of this circle. First of all, I will define the term of a peripheral angle. Actually, a peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. So I will read again the definition of a peripheral angle. A peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. Again, the peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. I will give you an example of a peripheral angle. Actually, angle alpha is a peripheral angle because, first of all, angle alpha is inside the circle. Then the vertex of angle alpha is at point A, and point A is a point on the circle itself, and the curve AB of angle alpha is chord in this circle, and also curve AC of angle alpha is chord in this circle. And actually angle alpha rests on chord BC of the circle. Okay, again, angle alpha is a peripheral angle because it is inside the circle. The vertex of angle alpha is at point A, and point A is a point on the circle, and the curve AB of angle alpha is chord in this circle, and also curve AC of angle alpha is chord in this circle, and actually angle alpha rests on chord BC in the circle. Okay, for that reason angle alpha is a peripheral angle. Okay, so in the next step we will draw a chord for points A and O. You should remember that point O is the center of this circle. So I will draw a chord for points A and O. And we will call to the touching point of the chord with the circle point M. Actually, chord AM is the diameter of this circle. I will write it down. Chord AM that I drew is the diameter of this circle. because it passes through the center of this circle that is to say for point O, that is the center of this circle. So I will read again the things that I wrote. Chord AM is the diameter of the circle. Chord AM that I drew is the diameter of the circle because it passes through the center of the circle. That is to say, it passes through point O, that is the center of the circle. Chord AM passes through the center of this circle, that is to say through point O, that is the center of this circle. For that reason, chord AM is the diameter of this circle. Actually, any chord that passes through the center of a circle, it is defined as the diameter of the circle, and point AM passes through the center of this circle, that is to say for point O, that is the center of this circle. For that reason, chord AM is the diameter of this circle. Okay? In the next step, we will connect together points D and M by a straight line. Okay. We connected together points D and M by a straight line. Actually, we have a rule. I will call it rule number 1. Rule number 1 states a peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will read again rule number 1. Rule number 1 states that a peripheral angle Rule number 1 states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, so any peripheral angle that rests on the diameter of a circle equals to 90 degrees. I will give you an example in order to clarify rule number 1. Suppose that chord BC is the diameter of this circle. So according to rule number 1, any peripheral angle that rests on this diameter of the circle will be equal to 90 degrees. So if we have a peripheral angle So peripheral angle BAC peripheral angle BAC rests on BC on chord BC and BC is the diameter of the circle Therefore, according to rule number 1, angle BAC equals to 90 degrees. Okay, so angle PAC will be equal to 90 degrees. So I'll read again the things that I wrote. Angle BAC, that is the peripheral angle, rests on chord BC. As you can see, angle BAC rests on chord BC, and chord BC is the diameter of the circle. For that reason, therefore, according to rule number 1, angle BAC equals to 90 degrees. Okay, so any angle that rests on the diameter of a circle will be equal to 90 degrees. I will give you another peripheral angle that rests on the diameter of a circle. Angle CDB, that is a peripheral angle, also rests on chord BC, that is the diameter of this circle. For that reason, peripheral angle CDB equals to 90 degrees according to rule number 1. Okay, so angle CDB equals to 90 degrees according to rule number 1. Okay, angle CDB or BDC, it is the same, equals to 90 degrees because of the fact that it rests on chord BC, that is the diameter of this circle. So according to rule number 1, it equals to 90 degrees. Okay. Actually, we can implement rule number 1 in our circle. Because we have angle ADM, or peripheral angle ADM, rests on chord AM, and chord AM is the diameter of this circle, therefore, according to rule number 1, angle ADM equals to 90 degrees. So actually, according to rule number 1, angle ADM equals to 90 degrees because of the fact that it rests on chord AM, that is the diameter of this circle. Okay. I will read again the things that I wrote. Angle ADM rests on chord AM. As you can see, angle ADM rests on chord AM, and chord AM is the diameter of this circle. For that reason, according to rule number 1 that states that any peripheral angle that rests on the diameter of the circle equals to 90 degrees, so peripheral angle ADM that rests on the diameter of this circle, that is to say on chord AM, equals to 90 degrees. Okay, so angle ADM equals to 90 degrees because it rests on the diameter of the circle, that is to say it rests on chord AM, that is the diameter of the circle. Okay. In the next step, we will focus on the right triangle ADM. Triangle ADM is a right triangle because of the fact that angle ADM equals to 90 degrees. So in the right triangle ADM, we will define angle DMA as alpha. So angle DMA equals to alpha. Okay. In the right triangle ADM, angle DMA equals to alpha according to our definition, and angle MAD will be equal to beta. Okay, angle MAD equals to beta. Okay, angle MAD equals to beta. This angle equals to beta. Okay, so angle DMA according to our definition equals to alpha, and angle MAD equals to beta. As you have already know, the sum of the angles in any triangle on the world equals to 180 degrees, and it is especially true for the right triangle ADM. So actually we will create our first equation that states that the sum of the angles in the right triangle ADM equals to 180 degrees. Okay, so the sum of the angles in the right triangle ADM is alpha plus beta plus 90 degrees. So alpha plus beta plus 90 degrees equals to 180 degrees. Okay, so our first equation states that the sum of the angles in the right triangle ADM equals to 180 degrees. The sum of the angles in the right triangle ADM is actually alpha plus beta plus 90 degrees, and it equals to 180 degrees, and as I've already told you, it is true for any triangle in the world, and especially in triangle ADM. The sum of its angles, that is to say alpha plus beta plus 90 degrees, equals to 180 degrees. Now we will subtract 90 degrees from equation number 1. So we subtracted 90 degrees from equation number 1. Alpha plus beta plus 90 degrees minus 90 degrees equals to alpha plus beta, and 190 degrees minus 90 degrees equals to 90 degrees. In the next step, we will subtract alpha from equation number 1. So we subtracted alpha from equation number 1. Alpha plus beta minus alpha equals to beta, and 90 degrees minus alpha equals to 90 degrees minus alpha. So we got in the first equation that beta equals to 90 degrees minus alpha. Okay, in the next step we will connect together points A and B by a straight line. Okay, we connected together points A and B by a straight line, and we also will define the vertex of the right angle SL. Okay, this angle is a right angle, and its vertex will be defined as point L. Okay, so we actually created right triangle ABL. Triangle ABL is a right triangle because this angle equals to 90 degrees. We actually have rule number 1 that states rule number 2 rule number 2 rule number 2 if two angles or if two peripheral angles rest on the same chord, then they are equal to each other. Okay, so I write it down. Or we can say that peripheral angles that rests on the same chord or the same arc are equal to each other. So I will read rule number 2 again. Rule number 2 states that peripheral angles that rest on the same chord or same arc are equal to each other. So in order to clarify rule number 2, I will give you an example. So if we have two peripheral angles that rest on the same chord or same arc, we have peripheral angle alpha peripheral angle alpha rests on chord BC. As you can see from the drawing, peripheral angle alpha rests on chord BC. And we have another peripheral angle beta that rests on the same chord BC. So as you can see from the drawing, peripheral angle beta also rests on the same chord BC. So we have two peripheral angles alpha and beta that both of them rests on the same chord BC. Okay? So according to rule number 2, they are equal to each other, that is to say alpha equals to beta. So I will write it down. So because of the fact that both peripheral angles rest on the same chord, that is to say on chord BC, according to rule number 2, they are equal to each other. That is to say alpha equals to beta. So I'll read again the things that I wrote. Because of the fact that both peripheral angles alpha and beta rest on the same chord, that is to say BC, as you can see from the drawing, angle alpha rests on chord BC and angle beta also rests on the same chord BC. According to rule number 2, they are equal to each other. So according to rule number 2, peripheral angles that rest on the same chord are equal to each other, and because of the fact that both peripheral angles alpha and beta rest on the same chord, that is to say on chord BC, they are equal to each other, that is to say alpha equals to beta. Okay? According to rule number 2, alpha equals to beta because of the fact that both those peripheral angles rest on the same chord BC. Okay, so we actually can implement rule number 2 in our circle. Usually angle AMD equals to alpha and it rests on chord AD. I write it down. Angle AMD equals to alpha, and it rests on chord AD. As you can see from the drawing, angle AMD rests on chord AD, and angle BAD or angle ABD also rests on chord AD, and angle ABD also rests on the same chord AD. So I will read again the things that I wrote. Angle AMD equals to alpha and it rests on chord AD. I read again. Angle AMD equals to alpha and it rests on chord AD. Angle AMD equals to alpha and it rests on chord AD, and angle ABD also rests on the same chord AD. Angle ABD also rests on the same chord AD. So we actually have angle alpha that rests on chord AD, and also angle ABD rests on the same chord AD as angle alpha. So because of the fact that both those two angles, angle alpha and angle ABD, rests on the same chord AD, according to rule number 2, they are equal to each other. That is to say, angle ABD equals to alpha. Okay, so according to rule number 2, because of the fact that those two angles, angle alpha and angle ABD, rests on the same chord, that is chord AD, because alpha and angle ABD rests on the same chord, that is to say on chord AD, they are equal to each other according they are equal to each other. They are equal to each other, that is to say angle ABD equals to alpha. So I read again the things that I wrote. So according to rule number 2, because angle alpha and angle ABD rests on the same chord, that is to say on chord AD, they are equal to each other. That is to say angle ABD equals to alpha. Okay? We have two peripheral angles that rest on the same chord. Therefore, according to rule number 2, they are equal to each other. Okay? That is to say angle ABD equals to alpha. Very simple. Okay? As you can see from the drawing, we have angle alpha that rests on chord AD, and angle ABD also rests on the same chord AD. So according to rule number 2, they are equal to each other. That is to say angle ABD equals to alpha. That's all. Okay? So angle ABD equals to alpha, so I will write here that angle ABD equals to alpha. Okay? This angle ABD equals to alpha. According to rule number 2. In the next step, we will focus on the right triangle ABL. So on the right triangle ABL, we will define angle BAL as X. So this angle BAL is defined as X. I will write it down. Angle BAL equals to X. Again, in the right triangle ABL, angle BAL equals to X. Okay, on the right triangle ABL, angle BAL equals or defined as X, equals to X. And as I've already mentioned, the sum of the angles in any triangle in the world equals to 180 degrees, and it is especially true for the right triangle ABL. The sum of its angles equals to 180 degrees. So we create the second equation that states that the sum of the angles in the right triangle ABL equals to 180 degrees, okay? The sum of the angles in the right triangle ABL is actually x plus alpha plus 90 degrees. And it equals to 180 degrees. Okay, so our second equation states that the sum of the angles in the right triangle ABL equals to 180 degrees. And what is the sum of the angles in the right triangle ABL? It is actually x plus alpha plus 90 degrees. X plus alpha plus 90 degrees is the sum of the angles in the right triangle ABL, and it equals to 180 degrees. Okay, we'll subtract from equation number 2 90 degrees. So we subtracted from equation number 2 90 degrees, x plus alpha plus 90 degrees minus 90 degrees equals to x plus alpha, and 180 degrees minus 90 degrees equals to 90 degrees. In the next step, we will subtract alpha from equation number 2. So we subtracted alpha from equation number 2. X plus alpha minus alpha equals to x, and 90 degrees minus alpha equals to 90 degrees minus alpha. And so equation number 2 states that x equals to 90 degrees minus alpha. But we know from equation number 1 states that beta also equals to 90 degrees minus alpha. We have found out that beta also equals to 90 degrees minus alpha. That is equation number 1. So I write it down. So according to equation number 1 that we created, beta also equals to 90 degrees minus alpha. And equation number 2 states that x equals to 90 degrees minus alpha. So we can integrate these two equations in one equation. So according to equation number 2, x equals to 90 degrees minus alpha. According to equation number 2, x equals to 90 degrees minus alpha. I copied it here. X equals to 90 degrees minus alpha. That is equation number 2. But equation number 1 states that 90 degrees minus alpha equals to beta. Equation number 1 states that 90 degrees minus alpha equals to beta. So I can write here that 90 degrees minus alpha equals to beta according to equation number 1. Okay, it equals to 90 degrees minus alpha equals to beta. According to equation number 1, 90 degrees minus alpha equals to beta. 90 degrees minus alpha equals to beta. And according to equation number 2, x equals to 90 degrees minus alpha. So I integrated those two equations, and from that integration we got the equality that states that x equals to beta. Okay, you can see from the equality that we have the equality that states that x equals to beta. Okay, so I write it down. X equals to beta. Okay, we have the equality that x equals to beta, so I wrote it here, x equals to beta. So actually we can substitute x here by beta because x equals to beta. Okay, so actually x equals to beta, so actually angle BAL equals to beta. I substituted x by beta, and we can say that angle BAL equals to beta in the right triangle BAL. Or it is also true that angle BAC also equals to beta, because it is the same angle. Angle BAC equals to angle BAL. They are the same angle, and both of them equals to angle beta. Okay, so we actually have rule number 3. Rule number 3 states equal peripheral angles rests on equal chords. Chords slash arcs. Okay, So rule number 1 states that equal peripheral angles rest on equal chords or equal arcs. So in order to clarify rule number 3, I will give you an example. So if we have two peripheral angles that are equal to each other, for example, so this peripheral angle will be called alpha, and peripheral angle alpha rests on the red chord. Peripheral angle alpha rests on chord BC. In the blue color, yes? We have another peripheral angle that is also peripheral angle alpha. The red peripheral angle alpha also rests on the same chord BC. So we actually have the blue peripheral angle alpha that rests on chord BC, and we have the red peripheral angle alpha that also rests on the same chord BC. So according to I made a mistake here. I made a mistake. So if we have peripheral angle alpha in the red color, that so peripheral angle alpha in the red color rests on chord BC, while peripheral angle alpha in the blue color so peripheral angle alpha in the blue color rests on chord EF. So according to rule number 3, equal peripheral angles rest on equal chords. The red peripheral angle rests on chord BC and the blue peripheral angle alpha rests on chord EF. So because of the fact that those both peripheral angles are equal to each other, they rest on equal chords. That is to say, BC equals to EF. Okay, so I write it down. The red peripheral angle alpha rests on chord BC while the blue peripheral angle alpha rests on chord EF So according to rule number 3, equal peripheral angles rest on equal chords. So because of the fact that those two peripheral angles are equal to each other, they also rest on equal chords. That is to say, BC equals to EF. Okay, so I will write it down. Because those two angles are equal to each other, both of them equal to alpha. According to rule number 3, they rest on equal chords. That is to say, BC equals to EF. So I read again the things that I wrote. The red peripheral angle alpha rests on chord BC. As you can see here, the red peripheral angle alpha rests on chord BC, and the blue peripheral angle alpha rests on chord EF. The blue peripheral angle alpha rests on chord EF. Okay, blue peripheral angle alpha rests on chord EF. Because those two angles are equal to each other, both of them equal to alpha, according to rule number 3, they rest on equal chords. That is to say, BC equals to EF. That is to say, BC equals to EF. Okay, so I will explain again. We have two peripheral angles that are equal to each other, both of them equal to alpha. And the red peripheral angle rests on chord BC, while the blue peripheral angle alpha rests on chord EF. So because of the fact that those two angles are equal to each other, they both rest on equal chords. That is to say, BC equals to EF. Very simple. Because of the fact that those two peripheral angles are equal to each other, they both equals to alpha. According to rule number 3, they rest on equal chords. The red angle alpha rests on chord BC, and the blue angle alpha rests on chord EF, and according to to rule number 3, they rest on equal chords. That is to say, BC equals to EF, that's all. Because equal peripheral angles rest on equal chords. Those two peripheral angles are equal to each other, both of them equals to alpha, so they also rest on equal chords. That is to say, BC equals to EF. Okay, so equal peripheral angles rest on equal chords according to rule number 3. Those two peripheral angles equal to each other, both of them equal to alpha, so they also rest on equal chords. That is to say, BC equals to EF. Okay? Okay, so according to rule number 3, we got that PC equals to EF. PC equals to EF. So actually we can implement rule number 3 in our circle. We have peripheral angle beta, so write it down. Angle BAC, angle BAC equals to beta. Again, angle BAC equals to beta, or peripheral angle BAC equals to beta. Again, peripheral angle BAC equals to beta. And it rests on chord peripheral angle BAC that equals to beta rests on chord BC. While peripheral angle MAD peripheral angle MAD also equals to beta, and it rests on chord MD. Okay, peripheral angle MAD that equals to beta rests on chord MD. So we have peripheral angle beta that rests on chord BC, and we have other peripheral angle beta that rests on chord MD. So according to rule number 3, they rest those two angles that are equal to each other, that is to say they both equal to angle beta, they rest on equal chords. That is to say BC equals to MD. Okay? So according to rule number 3, that equal peripheral angles rest on equal chords, according to rule number 3, they rest on equal chords. That is to say, PC equals to MD. So I will read again the things that I wrote. Peripheral angle BAC equals to beta and it rests on chord BC. Peripheral angle BAC equals to beta and it rests on chord BC. While peripheral angle MAD that also equals to beta rests on chord MD. While peripheral angle MAD that also equals to beta rests on chord MD. Okay? So according to rule number 3, because of the fact that they are equal to each other, those two peripheral angles are equal to each other, they rest on equal chords. Okay? Because of the fact that those peripheral angles are equal to each other, they rest on equal chords. Because equal peripheral angles rest on equal chords. That is rule number 3. That is to say, BC equals to MD. Okay? I will explain again. Peripheral angle BAC equals to beta and it rests on chord BC. While peripheral angle MAD that also equals to beta rests on chord MD. So according to rule number 3, equal peripheral angles rest on equal chords. And those two peripheral angles are equal to each other. They both equal to beta. So according to rule number 3, they rest on equal chords. That is to say, BC equals to MD. because angle beta rests on chord BC, and the other angle beta rests on chord MD, and according to rule number 3, they rest on equal chords. So BC equals to MD, because equal peripheral angles rest on equal chords. This peripheral angle that is beta rests on chord BC, and this peripheral angle that also equals to beta rests on chord MD, and according to rule number 3, equal peripheral angles rest on equal chords. So chord BC equals to chord MD. Okay? So we know that according to rule number 3, BC equals to MD. Okay? Chord BC equals to chord MD, but it is given us in the question that BC equals to 5 units. As you can see here, BC equals to 5 units because it is given us in the question. So we actually can add to this equality that BC equals to 5 units. Okay? It is given us in the question that BC equals to 5 units. So we have that equality that says that MD equals to 5 units. MD equals to 5 units. Okay? MD equals to 5 units. Okay? MD equals to 5 units. MD equals to 5 units. So we can write here that chord MD equals to 5 units. Okay? Chord MD equals to 5 units. And in the next step we'll draw again the right triangle AMD. So I draw again the right triangle AMD. We know that side AD of the triangle equals to 10 units, side MD equals to 5 units, and AM is the diameter of the circle. As you already know, okay, so AM, that is the diameter of the circle, I will mark it as D, abbreviation for diameter. So AM will be equal to D. And AM is actually the diameter of the circle that, as you already know, any diameter of circle equals to 2 times the radius. So after we will find out the diameter, we will divide the outcome by 2 and we will find out the radius of the circle. Okay, first of all, in order to find out the value of d, we will use the Pythagorean theorem. So the Pythagorean theorem states Pythagorean theorem correct only on right triangles. In order to apply it, it must be a right triangle. So in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So I will read the Pythagorean theorem again. The Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, so we will implement the Pythagorean theorem in our right triangle. So actually, the square of the hypotenuse is am squared. That will be our further question. Am squared equals to the sum of the squares of the perpendiculars. Am squared equals to ad squared plus md squared. So according to the Pythagorean theorem, we got that am squared equals to ad squared plus md squared. But we know that ad equals to d, am equals to d. The hypotenuse of the right triangle equals to d. ad equals to 10 units and md equals to 5 units. Okay, so I will write it down. Am equals to d is the diameter of the circle. AD equals to 10 units. And MD equals to 5 units. Okay. AM equals to D, this is the diameter of the circle, AD equals to 10 units, and MD equals to 5 units. So we can substitute AM in the third equation. We can substitute AM by D, and we will substitute AD by 10 units because AD equals to 10 units, and we will substitute MD by 5 units because MD equals to 5 units. Okay. So after we put the data in equation number 3, we got that d square equals to 10 square plus 5 square. 10 square is 100, 5 square is 25, 100 plus 25 equals to 125, so I write it down. So we got that d square equals to 125. Now we will take a root out of equation number 3. So we got that d equals to root of 125, but 125 equals to 25 times 5, so I write it down. Okay, instead of root 125, I wrote 25 times 5, because 25 times 5 equals to 125. In the next step, we can split the root, this root, to 2 roots, according to the rule that the root of a times b equals to root a times root b. So, okay, we have a rule that states that the root of a times b equals to root a times root b. So we can write that d that equals to root of 25 times 5 will be equal to okay, here instead of root of 25 times 5, I split the root to 2 roots, according to this rule, and I got that d equals to, instead of root 25 times 5, d equals to root 25 times root 5. We know that the root of 25 is 5, so I write it down. The root of 25 is 5, so we got that d equals to 5 times root 5. But we know that the diameter of any circle, d is the diameter of the circle. Yes, d equals to am, and am is the diameter of the circle, and we know that the diameter of any circle in the world equals to 2 times the radius. So we can write the fourth equation that states the diameter, this diameter, that is d, equals to 2 times the radius of the circle. Okay, it is true for every diameter in the world. The diameter of any circle equals to 2 times the radius. Okay, d, that is the diameter of the circle, equals to 2 times the radius. Okay, that is the fourth equation. But in the third equation, we know that d equals to 5 times root 5, so we can substitute d in the fourth equation by 5 times root 5, because d equals to 5 times root 5. So we substituted d by 5 times root 5. We got that 5 times root 5 equals to 2 times the radius. Now we'll divide the equation number 4 by 2, and we will get the radius of the circle. So we divided equation number 4 by 2. We got that the radius of the circle equals to 5 times root 5 over 2. Or we can also write that the radius of the circle equals to 5.59 units. So the radius of the circle is 5 times root 5 over 2 units. Or we can also say that the radius of the circle equals to 5.59 units. Okay, so the radius of this circle equals to 5.59 units, so it equals to 5 times root 5 over 2 units. Okay, so that is the answer to the question. Now I'll summarize the lecture. Actually, we wanted to find out the radius of this circle. The center of this circle is at point O. Chord AD equals to 10 units, chord BC equals to 5 units, and angle ALB equals to 90 degrees. And we want to find out the radius of this circle. Okay. So, in the first step, I explained the definition of peripheral angle, and actually a peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. Okay. So I will repeat again on the definition of a peripheral angle. A peripheral angle is an angle inside the circle that its vertex is on the circle and its curves are chords in the circle. So I gave you an example of a peripheral angle. Actually, alpha is a peripheral angle because it is in the circle, inside the circle, and the vertex of angle alpha is at point A, and point A is a point in the circle itself, and chord AB or curve AB of angle alpha is a chord in this circle, and also curve AC of angle alpha is chord in this circle. Okay, so that is the definition of a peripheral angle. Okay, actually in the next step we drew chord for points A and O. You should remember that point O is the center of this circle, and the touching point of the chord that I drew is at point M, or the touching point between the circle and the chord is at point M, and actually chord AM is the diameter of the circle because it passes through the center of the circle. That is to say, it passes through point O, that is the center of the circle. For that reason, chord AM is the diameter of this circle. Okay. In the next step, we connected together by a straight line points M and D, and we have rule number 1 that states that a peripheral angle that rests on the diameter of a circle equals to 90 degrees. So I gave you an example of a peripheral angle. Actually, peripheral angle BAC rests on chord BC, and chord BC is defined as the diameter of this circle. For that reason, according to rule number 1, angle BAC equals to 90 degrees. So any angle that rests on the diameter of a circle equals to 90 degrees. For that reason, also angle BDC that rests on the diameter of the circle, that is to say on BC, equals to 90 degrees, because any peripheral angle that rests on the diameter of a circle equals to 90 degrees. Okay, so we actually can implement rule number 1 in our circle, because we have angle ADM that rests on chord AM, and chord AM is the diameter of the circle. For that reason, angle ADM equals to 90 degrees. Okay, in the next step we defined angle DMA is alpha and angle MAT is beta. And as you have already know, the sum of the angles in any triangle in the world equals to 180 degrees, and it is especially true for the right triangle AMD. The sum of its angles equals to 180 degrees. So we created equation number 1 that states that the sum of the angles in the right triangle ADM equals to 180 degrees, that is to say alpha plus beta plus 90 degrees equals to 180 degrees. So equation number 1 states that the sum of the angles in the right triangle ADM equals to 180 degrees. Okay, so we got that beta equals to 90 degrees minus alpha. That is our first equation. And we have rule number 2 that states that peripheral angles that rest on the same chord or same arc are equal to each other. So if we have two peripheral angles, alpha and beta, that both of them rest on the same chord, so you can see from the drawing, both of those two angles, alpha and beta, rest on chord BC. So both of them rest on the same chord. Then they are equal to each other. That is to say, according to rule number 2, alpha equals to beta because of the fact that both those two angles rest on the same chord BC. Okay? So we actually can implement the rule in our circle. In our circle, we have angle AMD that equals to alpha, and it rests on chord AD. Again, angle AMD equals to alpha, and angle alpha rests on chord AD. And we also have angle ABD. Angle ABD rests also on chord AD. So we have two peripheral angles that rests on the same chord, that is to say on chord AD. Both peripheral angles, alpha and ABD, rest on the same chord, that is to say chord AD. So according to rule number 2, because angle alpha and angle ABD rest on the same chord AT, they are equal to each other. That is to say, this angle equals to this angle, so angle ABD equals to alpha. Okay, because of the fact that both those two angles rest on the same chord AD. So according to rule number 2, they are equal to each other. So if this angle is alpha, this angle is also alpha, so angle ABD equals to alpha. Okay. Then we focus, we connected together points A and B to a straight line, and we focused on the right triangle ABL. The sum of the angles in the right triangle ABL equals to 180 degrees. And that is our second equation that states that alpha plus angle X plus 90 degrees equals to 180 degrees. Okay, our second equation states that the sum of the angles in the right triangle in BL equals to 180 degrees. X plus alpha plus 90 degrees equals to 180 degrees. So we got from equation number, that is our second equation. Equation number 2, we got from equation number 2 that x equals to 90 degrees minus alpha. But from equation number 1, we already know that beta also equals to 90 degrees minus alpha. So we integrated those two equations together. We have equation number 2 that states that x equals to 90 degrees minus alpha. And we have the first equation that states that 90 degrees minus alpha equals to beta. So we can add here that 90 degrees minus alpha equals to beta. According to equation number 1 and according to equation number 2, x equals to 90 degrees minus alpha. So we integrated those two equations together and we got that x equals to beta. Okay, so we actually can substitute angle BAL instead of x. We can write down that it equals to beta because x equals to beta. Okay, and we have rule number 3 that states that equal peripheral angles rest on equal chords or equal arcs. So if we have two peripheral angles that both of them equals to alpha, so they are equal to each other, then according to rule number 3, they rest on equal arcs. That is to say, BC also will be equal to EF. So because of the fact that those two angles, peripheral angles, are equal to each other, they both also rest on the on equal chords. That is to say, BC equals to EF. Okay. Okay, so according to rule number 3, because of the fact that those two peripheral angles are equal to each other, equal peripheral angles rest on equal arcs. Those two peripheral angles are equal to each other, both of them equals to alpha, so they rest also on equal arcs, on equal chords. That is to say, BC equals to EF. Okay, so we can implement rule number 3 in our circle. We have angle BAC that rests on chord BC. So angle BAC that equals to beta rests on chord BC, and angle MAD that also equals to beta rests on chord MD. So those two angles are equal to each other, both of them equal to beta. So according to rule number 3, they rest on equal arcs. That is to say BC equals to MD. Okay? So according to rule number 3, because of the fact that those two angles are equal to each other, both of them equals to beta, they also rest on equal arcs. That is to say BC equals to MD. Okay? But we already know that BC equals to 5 units. According to rule number 3, BC equals to MD, but we know from the question that BC equals to 5 units. Okay, so from this equality we can deduce that MD also equals to 5 units. Okay, so I draw the right triangle ADM again. We know that side MD equals to 5 units, side AD equals to 10 units, and AM is the diameter of this circle, so we mark it as D. Okay, side AD equals to 10 units, side MD equals to 5 units, and AM is the diameter of the circle, so we mark it as D. So we can use the Pythagorean theorem in order to find out the value of D, because it is a right triangle. So the Pythagorean theorem states that in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So it is true only in right triangles. According to the Pythagorean theorem, the square of the hypotenuse, that is to say AM square, equals to the square of the sum of the squares of the perpendiculars. That is to say AM square equals to AD square plus MD square, according to the Pythagorean theorem. Okay, so we have the equation that states that AM square equals to AD square plus MD square, but we know that AM equals to D, AD equals to 10 units, and MD equals to 5 units, so we can put the data in equation number 3, and we actually found out that D equals to 5 times root 5. D is the diameter of the circle. Okay, but we have the general formula that states that the diameter of any circle equals to 2 times the radius. That is our fourth equation. The diameter of any circle equals to 2 times the radius. D is the diameter of the circle because D equals to AM, and AM is the diameter of the circle. So in general we know that in any circle the diameter of the diameter equals to 2 times the radius. Its diameter equals to 2 times the radius. And it's also true in our specific circle. So we have this equation that D equals to 2 times the radius, but we found out that D equals to 5 times root 5. So we can substitute D by 5 times root 5. So we substituted D by 5 times root 5, and we got that 5 times root 5 equals to 2 times the radius. We divided equation number 4 by 2, and we got that the radius of the circle equals to 5 times root 5 over 2 units. Or we can also say that the diameter of the circle, the radius of the circle equals to 5.59 units. Okay, so the diameter of this circle equals to 5.59 units, so we can also say that the diameter of this circle equals to 5 times root 5 over 2 units. Okay, thank you very much.